Okay, so now that we know the process of completing the square, it looks like I just misspelled it. All right, let's practice completing the square. So again, those steps off to the side here, right? The first thing I want to do, right, is make sure that my lead coefficient is 1. And so in my first example that I have, that is not the case. So we have to make sure, right, that, or excuse me, that is the case, right? So we have a 1 there, so that's good news. Second thing we need to do is isolate the incomplete square terms. Well, again, the incomplete square is always of the form x squared plus or minus bx. So there's the two terms representing the incomplete square that are already isolated. So we're down to step 3, right? We're going to take whatever b is and divide it by 2. So in this case, 12 divided by 2 is a 6. Hold on to that. That's a very important number for us, because first off, what I have to do is square it to give us the square that result, because that gives us the area of that little missing chunk that needs to be added. So that's step 5 now. We're going to add that result to complete the square. So we're going to take our incomplete square, add 36 to it. To be in balance, whatever I do to one side, I have to do the same thing to the other. This is now a perfect square trinomial. That 6 is going to play a role in its factorization. It'll factor as x plus 6 squared. And then 13 plus 36, that adds up to 49. So by design, the whole reason why we're completing the square is to do what we have there, which is to set up our square root property to finish. And so that's basically what we'll do next. Taking a square root of both sides, I've introduced a plus minus via the square root property. This gives us an x plus 6, and that gives us a plus or minus 7. So we have two potential answers, right? X plus 6 is 7, or x plus 6 is negative 7. So subtracting 6 from both sides, we get 1 as an answer. Subtracting 6 from both sides, we get negative 13. So there's our two answers. Alrighty. So there's the process. Completing the square sets up the square root property, which sets up a plus minus situation, sets up two equations to solve, everything coming together. So the next one, again, let me kind of have our steps here. Make sure the lead coefficient is 1. It is. Isolate the incomplete square terms. Well, there they are. So that 9's in the way. So we'll subtract 9 from both sides and get x squared minus 10x equals negative 9. So our next move now is to take whatever b is and divide it by 2. So negative 10 divided by 2 gives us negative 5. Hold on to that number, right, because it's going to be important. We're going to square that result. And so 25 represents the little missing chunk that we need to complete this square. So step, where are we at? Yeah, step 5, we're going to take our incomplete square and we're going to add 25. Of course, to be in balance, we have to add 25 to the other side. This is now a perfect square trinomial with negative 5 playing a role. So that's x minus 5 squared, and negative 9 plus 25 is 16. So we now have set up our square root property, and so we can use that property to finish. So taking the square root of this side, add plus or minus to that side, we get x minus 5 equals plus or minus 4. So that means x minus 5 is either positive 4 or x minus 5 is negative 4. Adding 5 to both sides, we get 9 as a solution. And adding 5, it looks like we get 1 as a solution. So 9 and 1 are the two things that solve it. Of course, you can check it if you want. So there you go. All right, C should be a little familiar. I think when I first was introducing quadratics, we realized that this didn't factor. So we needed definitely something new, and completing the squares are something new. So going through our steps, my lead coefficient is 1, so that's good. The terms that represent the incomplete square are not isolated, so I'll subtract 2 from both sides. So that gives us x squared minus 2x equals negative 2. To complete the square, I need to take whatever b is and divide it by 2, so that gives us negative 1. And again, keep that number around, it's important. We're going to square it, and that's the missing chunk, right? That's the area that needs to be added to the incomplete square. So my next step is to add 1. Of course, whatever I do to one side, I do the exact same thing to the other. This is a perfect square trinomial with negative 1 serving as a role. So we get x minus 1 squared. Negative 2 plus 1 is negative 1. And so now we've set up our square root property. So I'll take the square root of both sides. I've introduced a plus minus because I introduced that square root. This side is x minus 1, and we have plus or minus I. And again, there's two solutions here, right? This is either I or it's negative I. And in all cases, I'll add 1 to both sides, and we get x equals 1 plus I, x equals 1 minus I. And so very complex solution there. Yeah, so basically in this one we have a system that is resonant. So it's going to keep bouncing back and forth, and the waves are going to keep getting bigger and bigger and bigger, which is actually not a good situation when you think in terms of vibration and all that. But I'm way ahead of us, right? That's some calculus subject and engineering subjects. I just want to give some meaning. Even though we're getting imaginary answers, they have very real applications. Okay, so but that would be the solution to C. So there you have it. All right, so let's just keep working. The next one, our first one, the challenge is that the lead coefficient is not 1, it's 3. So I'll basically divide everybody by 3, and that'll give us x squared. 24, that would be 8x, and 7 equals 0. And so isolate the incomplete square parts. We get that, right? We're going to subtract 7 from both sides. To start completing the square, I'll take whatever b is and divide it by 2. Again, that's going to play an important role, so kind of keep it around. And squaring it, we get 16. So to complete the square here, I add 16, and to balance myself off, I add 16. And so this is a nice complete square, right? A perfect square trinomial, and that's a 9. So taking the square root of both sides, we have x plus 4 equals plus or minus 3. Alright, and so we either have that equal to 3 or we have that equal to negative 3. And if we subtract all the way around, one of our answers is negative 1, and it looks like another answer is negative 7. Right? So perfect, perfect, perfect. Again, getting a little tougher, or trying to, right? Our last example of at least this set. The good news is the x squared has a coefficient of 1, so that's positive. Right? Here's the thing that needs to be isolated. So really, even though there's a 12 there, the only thing I need to worry about is I need to subtract 2 from both sides. So that gives us x squared plus 3x equals 10. And so now we complete the square here. It's isolated, so I take 3 and divide it by 2, and unfortunately that's what we got. Square that result and we get 9 over 4. So what completes the square here is adding 9 over 4 to both sides. Right, now this side is a perfect square trinomial, and if you're following the pattern, right, this number plays a role. So this is x plus 3 halves squared. Over here we have to add fractions. So 10 fourths, or this becomes, I think, 40 over 4, right? Because we're going to multiply by 4 over 4. And 9 over 4, so this is 49 over 4. So that would be our answer there. And you can begin to see, I mean, not only are there a lot of steps to this, but because we're doing some dividing, right? We're dividing here to make sure the lead coefficient is 1, and we're dividing here to get that missing flap length, if you would. We start to introduce fractions. So sometimes we're really nice, like my first 4 examples, but then sometimes we do have fractions to push around. So good fraction work. Finishing this off, I have to take the square root of both sides. That introduces a plus or minus to that side. So we end up with x plus 3 halves. And of course this is plus or minus 7 over 2. Alright, because the square root of 49 is 7 and the square root of 4 is 2. So we have two possibilities, right? The x plus 3 halves is either 7 halves, or the x plus 3 halves is negative 7 halves. So if I subtract 3 halves from everybody, here's what we end up with. Here, 7 halves take away 3 halves is 4 halves, so we end up with 2 as an answer. And over here, negative 7 halves minus 3 halves is a negative 10 halves. So we're left with -5 as an answer. So there's your completing the square process. Hopefully you're starting to see the pattern or the steps. What I'm going to do in the next video is do some that are harder, things that involve fractions and whatnot. That'll get you kind of tired of it, and then we'll want to learn the quadratic formula. But another round of completing the square. Let's do some harder ones.